Today we're going to talk about completing the square, solving quadratics by completing the square. So the first thing, sorry, I have water on my table. First thing we're going to talk about, there we go, is right here. So it says for an expression of the form x squared plus bx plus, or x squared plus bx, you can add a constant c to the expression so that the expression x squared plus bx plus c is a perfect square trinomial. So before we go any farther, let me just remind you what that whole thing of Post-its just came out. Okay, what a perfect square trinomial is. That would be something like x squared. That's a perfect square. I'm having technical difficulties. That pen is dead. Okay, so like x squared plus 10x plus 25. This is a perfect square trinomial because this is a perfect square and this is a perfect square, and 5 squared is 25, but 5 plus 5 is 10, because let's not forget what this means is x plus 5 times x plus 5. So 5 times 5 is 25, but 5x plus 5x is 10x. Or x squared plus 14x, or we could even put a minus here, minus 14x plus 49, right? Where that would be x minus 7 squared. Negative 7 times negative 7 is 49, but negative 7 plus negative 7 is negative 14. These are perfect square trinomials. So essentially what we're going to be doing is we're going to figure out what can I put in there if I have an x squared plus bx. What can I put in for c to make it a perfect square trinomial? Because then we can solve the equations just like we did in the last section. So we're actually going to skip number 1. It's a little more complicated because it's a fraction. So we're going to come down, we'll come back to number 1. We're going to look at number 2. Okay, so on every single one of these, the first thing we have to do is we're trying to figure out what is c. Okay, so we're finding out what c is, and then we're going to factor it. So what would I put in here to make this a perfect square trinomial? So what we do every time, c is equal to b over 2 squared. So here, b over 2 is 8 over 2, which is 4, and 4 squared is 16. So on number 2, c would be 16. So if I put a 16 in there, x squared plus 8x plus 16, this is now a perfect square trinomial. This is a perfect square, 16 is a perfect square. The square root of 16 is 4, so my binomial would be x plus 4 squared. 4 times 4 is 16, but 4 plus 4 is 8. Okay, let's look together at number 3. So to get our c value, remember to get c, we're going to do b over 2, so negative 12 over 2, and then we're going to square it. Negative 12 over 2 is negative 6. We're going to square it to get 36. So this is the value of c. And by doing that, my trinomial is x squared minus 12x plus 36. And when I factor that, the binomial would be x and then minus 6 squared. Because negative 6 times negative 6 is 36, but negative 6 plus negative 6 is negative 12. And then number 4, same thing. We're going to do b over 2 squared. 3 squared is 9. 2 squared is 4. Okay, it's a fraction. When you square it, it just means 3 over 2 times 3 over 2, 9 over 4. So that's my c value. And so for my trinomial, I would have x squared plus 3x plus 9 over 4. So to find out, well, how would I factor that? This is a perfect square, then it's a plus sign. The square root of 9 over 4 is 3 over 2 squared. Okay, so now let's come back up here to number 1. I feel like it's a little bit easier to look at it now. So on number 1, we're going to do the b is 5. So to find out what c is, we do b over 2 squared. 5 squared is 25, 2 squared is 4. So this would be the C value, 25 over 4. So if I were to plug it in up here for C, I would have x squared plus 5x plus 25 over 4. And so when it asks you, well, how would you factor that? Like, what would be the binomial? Well, the square root of x squared is x. The square root of 25 over 4 is 5 over 2, and that's squared. Okay, and again, I just want to show you one more time that what this means is x plus 5 over 2 times x plus 5 over 2. So when we did FOIL, because it's two binomials, x times x is x squared. 5 over 2x plus 5 over 2x, right? Because x times 5 over 2 is 5 over 2x. 5 over 2 times x is 5 over 2x. And then 5 over 2 times 5 over 2 is 25 over 4. So look what happens when you have 5 over 2 plus 5 over 2. That's 10 over 2x. And what's 10 divided by 2? 5. Okay, so why do we even care, right? Like, this is great. We can find out what C is. Okay, why does it matter? It matters because now we can solve these equations, these quadratics, by completing the square. So look with me at number 5. So I have x squared minus 16x, and then I'm going to complete it by adding some number, right? And that's going to equal negative 15 plus some number. Because think back to, gosh, like 5th grade, 4th grade maybe, when you started solving equations. You can do anything to an equation as long as you do the same thing to the other side. So if it's a balance scale, if I add 75 over here, that's fine as long as I add 75 over here on the right. So what we're going to fill in is we need to know, well, what's going to go in here? Well, that's what we just figured out, right? That's going to be completing the square. So to figure out what goes in this blank, we do b over 2 squared. So negative 16 over 2 is negative 8, and then we're squaring it. Well, negative 8 times negative 8 is positive 64. So that's what I'm filling in over here. And if I do that on the left, I have to add 64 on the right. Okay, and the whole reason, remember, that we've completed this square is because now I can factor it in the format x, because the square root of x squared is x, and then a minus, and then the square root of 64 is 8 squared. So negative 8 times negative 8 is positive 64, but negative 8 plus negative 8 is negative 16. And that equals negative 15 plus 64 is 49. Okay, is this looking familiar? I hope it is, because this is what we solved in yesterday's lesson. So we're going to take the square root of both sides. The square root of x minus 8 squared is x minus 8. And then remember, when you take the square root, it could be plus or minus, right? Because, well, we know the square root of 49 is 7, but it could be positive 7 or it could be negative 7, because 7 times 7 is 49, but negative 7 times negative 7 is also 49. So we're so close. I just want x, though, not x minus 8. So we're going to add 8 to both sides. So x could be 8 plus or minus 7. So let's think about both solutions. Okay, 8 plus 7 would be 15. 8 minus 7 would be 1. And those are my two answers. Okay, once you get your answer, you should be able to plug in either one of these to get to make this a true equation on the top. Okay, so for example, if I plugged in, I think the first solution is 15. So if I plug in 15 for x, 15 squared minus 16 times 15, I should get negative 15 if it's correct. Negative 15, right? I think my other answer should be 1. So 1 squared minus 16 times 1, is just 16, equals negative 15. These two answers, okay, are what makes this true. If we were to graph this, right, on a coordinate plane, it would open up, our parabola would open up, and it would cross at 1 and 15. Okay, let's look at number 6. So we're going to do the exact same process. Okay, we're going to do, let's see, we have x squared minus 2x plus some mystery number equals 3 plus that same number, right? What can I put in here to complete the square? So I do b over 2 squared. Well, negative 2 over 2 is negative 1. And when I square negative 1, I get 1. So negative 1 squared is 1, so I put a 1 to complete my square. And if I add 1 over here, I have to add 1 to the right. So now my trinomial is x squared minus 2x plus 1 equals 4. So remember, the whole reason I did this was so I can factor it into x minus 1 squared. Because negative 1 squared is positive 1, but negative 1 times 2 is negative 2. Okay, equals 3 plus 1 is 4. So I'm close, but I need to get rid of this squared. So I'm going to take the square root of both sides. So now I have x minus 1 equals plus or minus the square root of 4 is 2. I'm close, but I don't want x minus 1, I just want x, so I'm going to add 1 to both sides. So x equals 1 plus or minus 2. 1 plus 2 is 3. 1 minus 2 would be negative 1. And those are my two solutions. Okay, let's look up here at number 7, right? If I asked you to complete this by, or to factor this by completing the square, to solve it, excuse me, by completing the square. Okay, first of all, it's a trinomial. So let's divide everything by 2, because all of these numbers are divisible by 2. So we want it to just be x squared, so let's do that first. So that would give me x squared plus 10x minus 4 is 0, right? And this is why we learn these alternate methods, because is there any way I can split this into 2 binomials? Like, is there anything I can multiply to get negative 4 that adds to give me 10? No, not that I know of, right? So I want to get rid of this subtracting 4 by adding 4 to both sides. So what I have is x squared plus 10x plus some mystery number equals 4, right? Essentially, and then plus that same number. So I just wanted it to be x squared plus bx, and then I want to leave this blank to make it a perfect trinomial square. So I'm going to do the same thing, right? B over 2 squared. So that's 5 squared, which is 25. So that's what I'm putting in my blank. So now I can factor this. This is a perfect trinomial square. I have x squared and 25. So this is x plus 5 squared equals 4 plus 25 is 29. Okay, and now that I have that, right, I'm going to do it just like I did my other questions, my other problems. I'm going to take the square root of both sides. So I have x plus 5 equals plus or minus the square root of 29. This is the only part that's kind of different, right? Over here, we knew what the square root of 49 was. It's 7, right? Over here, I don't know the square root of 29, but that's okay. We're going to use our calculator to calculate it. So if I don't want this plus 5, I need to subtract it from both sides. So negative 5 plus or minus the square root of 29. So now on my calculator, I can type in negative 5 plus the square root of 29, which gives me, we're rounding to the nearest hundredth, so 0.39. Okay, or I could do negative 5 minus the square root of 29, which is negative 10.39. And those are my two solutions, right? So just because, like, I couldn't factor this. Remember when I said, like, okay, well, what could we set up? Like, you know, if this is my trinomial, then what we learned last chapter was like, okay, well, x times x makes x squared. And then what can I multiply to make 4 that adds to give me 10? And you're like, well, there isn't anything. Well, there is, and it's these two numbers down here. right? It would be x minus 0.39 and x plus 10.39. So if you typed it in, and it might come out close just because we'd left off a whole bunch and we rounded. So negative 0.39 times 10.39 is negative 4, right? And that's what I wanted. And if I add these two together, I get 10. So there actually are numbers that you can put in here. We just don't know those, right? Not like our whole numbers. So we have to use other methods like completing a square. Okay, one more. On number 8, okay, if you want, pause the video, try it on your own, and then come back and we'll see if you got it. So I have m squared plus 10m plus some number equals negative 8 plus that same number. I'm going to complete the square by doing 10 over 2 squared. That's 5 squared, which is 25. So 25 is going to go in both of my blanks. And what that leaves me with is m plus 5 squared equals negative 8 plus 25 is 17. So I want to take the square root of both sides. So I now have m plus 5 equals plus or minus the square root of 17. I need to bring that 5 over. So negative 5 plus or minus the square root of 17. So 5 plus the square root of 17 is 9.12. Oh, except it's negative 5. Negative 5 plus the square root of 17 is negative 0.88. And then negative 5, this is why I like this calculator, because you can see everything and you can just up arrow and change your sign or your symbol. Negative 5 minus the square root of 17 is negative 9.12. And those are my two solutions.